This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and my guest today is Markus Borg. He is principal researcher at CodeScene, and Markus and I are going to talk about requirements engineering for AI. Hello, Markus.
Hello, thanks for having me.
Please introduce yourself to our listeners. Let us know what you do at CodeScene and maybe elsewhere as well.
So I've got a PhD in software engineering from Lund University, Sweden. I think that's a good starting point here. I'm also working 20% as an adjunct lecturer at the Department of Computer Science with Lund University. And this is a podcast about industrial AI, right?
Exactly.
Yeah, I did my homework. So my hands-on practical experiences related to this domain is an internship at Ford Motor Company in Cologne, Germany.
Right.
That was actually my first engineering kind of workplace. And then I worked for 3 years at ABB in Malmö, Sweden, with process automation. So this is my industrial background, I would say. Then I returned to the university to pursue a PhD, and I've been working with different flavors of the software industry since then, but it surely overlaps with the industrial AI. I worked for 7 years at a state-owned institute, RISE, Research Institutes of Sweden. It's somewhat similar to the Fraunhofer Institute in Germany, which I guess some of your listeners know about at least.
Some of them, yeah.
Yeah, running projects to bridge academic research and industry practice. Very wide variety of projects and very fun. And my research has always been at this intersection of software engineering and applied AI. And related to AI and requirements, I've mostly been working with the automotive industry and the machine learning-based perception systems. Now I just joined CodeScene last month as a principal researcher, so this is new, to drive research on software engineering intelligence, discovering new ways to develop better software faster. These would be the 3 words to describe it. And again, this is doing research at the intersection of software engineering and AI. And that goes in both directions. So with CodeScene, I do AI to improve software engineering. And with Lund University, I focus on adapting software engineering methods and practices for the AI era. And this is what we're going to talk about today, I believe.
Right. Sounds like there's more than enough material for talking about requirements engineering for AI. Interesting, you say you did an internship with Ford in Cologne. I did visit that factory while I was with German, what is that organization for the machine builders, VDMA. And I think they had a day or an afternoon there looking at how manufacturing works. So you were involved, I understand, in writing the IEEE software issue on AI engineering, realizing the potential of AI is what it says. What is that all about?
So we need some additional background here then.
Please do.
So I'm a department editor for requirements in the magazine IEEE Software. So this is a magazine. It's an industry-leaning magazine, I would say, that seeks to publish the latest and greatest in software technology by academics and thought leaders in the industry. This means I'm responsible for writing or inviting someone else to write a bi-monthly column on a timely topic related to requirements. And each issue of IEEE Software has a particular theme. And for the November-December issue 2022, and that's the current issue, the theme is AI engineering.
Right.
And AI engineering, it's a new name for a discipline concerned with all aspects of development and evolution of AI systems. So systems that somehow involve AI components, typically machine learning components. The column we're going to discuss today, it's a piece in this issue of IEEE Software, and it's a collaboration between Siemens Digital Industries, RISE, and the University of Cologne. We primarily did an interview study with AI stakeholders within Siemens, and we discussed the topic of requirements engineering for AI quite extensively. So Boris Scharinger from Siemens Digital Industries is actually the lead author of this column we talked about today, with support from me and Professor Andreas Vogelsang, University of Cologne, and Dr. Thomas Olsson with RISE. So these are the people involved.
Very good. So let's start talking about, you mentioned already AI engineering as a new terminology. Very happy to hear that because not that I hadn't heard about it, but there you go. So why don't you start explaining us more in general, one step higher up, I guess, what requirements engineering has been about.
Yes, that's a good start, of course. So I like to describe requirements engineering as structured expectation management or needs management, maybe taking the end user's perspective. And the term, it was coined in the 1960s, so it's been around for a while. From the late 90s, it turned into an academic discipline. So there are now conferences and workshops on this topic and has been around for a long time with a very strong representation in Germany, I would say. Also, Germany has always been a leading country here. And I think the essence of requirements engineering, I think it resonates very well with the quality-oriented focus of German engineering. Okay. There are different definitions of requirements engineering, but a simple and short one that you often come across is the process of defining, documenting, and maintaining requirements. This is particularly recognized then in software engineering and systems engineering. So it might sound a bit old-fashioned, and I don't like that. I mean, nowadays it sounds like, you do all the planning first, and then no, I must stress that requirements engineering doesn't at all mean that you work in a waterfall model. I mean, I teach in this also at the university, and I have a hard time making it sound interesting. So I try to, the word itself, requirements, doesn't maybe sound so positive.
Well, I'm not sure why you say that, but we can come to that at some point in time. That's interesting. But I hear you say, is this discussion we have all the time here in Europe, more strongly, maybe even so in Germany, where the young generation that has had the option, or all of us seeing where, many, let's say, typically American companies, software companies, if that's what you mean, bring a product to market and, here it is on the internet, try it out. And we get 5 times a day a new update, which I hear you say maybe have not been doing so strongly requirements engineering. On the other hand, the typical German approach of say, we need so long, we first do this. And then the young generation says, we're losing. We see all these companies. That's not necessarily true, by the way, right? But if that's what you mean with that it sounds old, that's what, for me, it doesn't sound old at all, but there you go.
That's good. But I always end up in this kind of defensive mode when I bring forward the topic, because it doesn't maybe resonate with the fail-fast generation, as you kind of implied. But there are certainly agile requirements engineering as well. When you integrate various activities in the rest of the development and iterate. But the important thing is to really maintain this end-user perspective. I think that's so important.
Very good. So at least I'll keep this in the end of my brain and maybe bring it up at the end or somewhere. So what is the main issue you are addressing here in this article, or in general, requirements engineering for AI? And maybe already as well, is there a main outcome before we then get to the details?
Well, the starting point of the column that we presented here, that's that AI, we know it's everywhere, and it promises many lucrative solutions. And of course, AI, it is amazing, but it's not magic. It's a technology that allows us to increase the levels of automation for tasks that previously were very difficult to tackle, using the old-fashioned hard-coded source code instructions. For certain types of problems, we know that it's way more feasible to collect massive amounts of data and help the machine then to find useful patterns. But, the issue, so it's opinionated, of course, it's a column, it's not a typical research article. It is that we haven't seen yet this steady stream of success stories from industrial AI. It turns out that it's not so easy to profit on AI. There is a business challenge to it. It's hard to reach what we refer to in our work as commercial scalability, to make money, if you will, get that return on investment. So this would be the issue then. Then our position here with this piece is that RE is in a very good position. RE, as in requirements engineering, is in a very good position to catalyze the maturing process of industrial AI and help with the adoption.
Exactly. So you mentioned the AI adoption in manufacturing process industry to be fairly low, and you talk about deaths by proof of concepts as a
Hmm.
widely occurring phenomenon. I must say that as I was involved in actually doing projects, that was exactly not the death piece, but we were always doing first a proof of concept as well. So I'm now very much interested in, well, number one, and what do you base this very idea on, that death by proof of concept is a widely occurring phenomenon?
It's not our term. We cannot take credit for
Okay.
the term. It's something you see among venture capitalists, for example.
Oh, right.
You
They
see a
say
lot
that.
of
Hmm.
proof of concept.
Yeah, but so are they suggesting that we shouldn't be doing any proof of concepts anymore? We
No,
should just immediately
no.
start and doing, because I'm teaching all the time, and maybe I'm going to do that differently after this talk, but I'm saying all the time, start small. Yes, start with a proof of
Mm,
concept. If
mm.
you find something that is working, then I say, well, start with a very small project. So interesting to hear your answer here.
Yeah, I need to balance that position a little bit, of course. I've been with the Research Institute, I was involved in many start your AI journey projects, pilot projects with various
Right.
customers, actually. And as you said, we one of the recommendations we do give our customers is to find some low hanging fruit, start with a proof of concept and learn from that. I mean, it would
Yeah.
help you get going, build the competencies you need, and so on. So it's not like you shouldn't stop doing the proof of concepts, but you should recognize and acknowledge that there might be a very big step after that one, right?
Okay. Yeah, you can continue. But yeah, sure. I mean, but that's, as I already said, after you would be doing POC. And then when before I, as a consultant or with a team of people who would learn from me, we would look at a list of potential use cases, where we could apply artificial intelligence to machine learning to. And then we would have a number of discriminators. And one of the driving discriminators would be the size of the project, right?
Mm.
If it is this huge thing, which we all want to do, and we know it's going to take us 3 years, then, that would only get 1 point out of 10, right?
Mm-hmm.
If it was this small thing, okay, and that has a real good feeling, it would get, 10 points. What I'm saying is, like, then, very many times, if the use case would have data and all the other things being equal as well, the small project will be the first one to then, try to work on. So I understand many argue that machine learning is yet another piece of technology. Would you agree, or is it something more than that?
Mm-hmm. Yeah, this is of course interesting. And in the IEEE issue of AI engineering, there is actually a debate in the end of the issue, which is quite interesting to follow, where there is a point and a counterpoint by some professors arguing for and against this. You can, of course, say that machine learning, it's a technique. It simply extends the toolbox we have. It's still software, right? Bits and bytes, they execute on some machine.
Sure.
You just need to learn how to use it properly. Well, requirements engineering is also, as a field, you should focus on what the systems should do and not put your requirements on how the system accomplishes that. So, and from that sense, yes, we hear that a lot, but we claim that machine learning, it is a disruptive technology with novel intricacies, and you need to master those during the development and evolution of systems. So my position is that, yes, we need to do a little bit more than just considering it as
I would agree to that. The time that we are recording is the end of the year. The time listeners, you are now listening, is the beginning of the year. And just today, I did a news update, and you may have heard that in between, which is, and you and I, Markus, are going to be talking later on also about, generative technologies and how we may include them, and maybe even, a word or two about ChatGPT. But, that's, and I'm not going to say now if that's good or bad, but there's so awfully way too many people saying, that's a technology. It's a piece coming out of whatever, let's say machine learning, artificial intelligence, that's going to be changing the world. I believe it's way too early, but we'll come to that later on. But at least I would agree with you that it's something more than just a new algorithm in a range of 100 algorithms or whatever. It's something I would agree that it feels bigger than that.
Yeah, you need to do more about that, of course. I mean, maybe I shouldn't go into that, but
no, we'll talk about that anyway. So why then? What are the reasons you see requirements engineering maybe as the main driver for maturation? I need to do that. I need to say that sentence again. That was wrong. So why? What are the reasons you see requirements engineering as a main driver for maturation? Right.
Yes. Now we're getting to the core of this column we're presenting, right? So requirements engineering, it gives you a framework to structure your thinking, and this is very, very valuable. So for example, you can use goal modeling as part of your business analysis to express what you really hope to achieve using your AI. So digitalization, of course, it comes with a cost, and you need to identify what kind of return on investment you're hoping to obtain. Do you hope to decrease on processing time? Are you seeking higher process quality? Do you want more predictability in the process? Do you want to decrease costs by automating things? Often it's a mix, and there might be contradictions here. So requirements engineering offers various ways to do trade-off analysis, for example. Prioritization is a big topic in requirements engineering. You can use more or less advanced optimization methods to set meaningful targets. It gives you a language to discuss those things. And also requirements engineering, it's interdisciplinary in its nature. Requirements engineers are good at talking to different stakeholders, are good at talking to business, good at talking to engineers. And I mean, the bridge building capabilities of requirements engineering is, to a large extent, we claim, what is needed to take the next step and support industrial adoption of many AI systems.
Right. So you just mentioned optimization. Now, I've been telling, companies for the last 5 years, I believe, to start with optimization. Very much interested in hearing from you. So what have been, as far as you see the market, the machine learning applications been lately? So maybe dividing between new solutions or, updating all things.
So I think you need to repeat the last question there because I didn't really get it. So the balance between new solutions and optimizing something existing?
Yeah, right. So you just mentioned optimization, and I've been telling, whoever wanted or did not want to hear it, is I've always been saying, we have, the companies that had or have been doing, general optimization, overall efficiency, effectiveness, have always been looking at, what is my theoretical quality? What is my theoretical throughput? And how far do I get, in discrete, typically, whatever. My feeling was, and my visit to Ford in Cologne was one of those, 50 places where I was invited to be, and not specifically for this side, but in general, 80, 90% in process, a lot less than that from the theoretical. And that's why I've always been saying, and now here's a new way of doing things on the basis of data and machine learning, finding patterns. And I've always been saying, use it to further optimize what you have. And my question is that what you have been seeing as well? Is that the one and only, machine learning that you have seen? Or have you also seen, completely new things that have nothing to do with optimization?
So that was the question. So by optimization, so I've had very close colleagues with the research institute that worked on classical optimization. So they were computer scientists of the old kind. You work with various optimization techniques that are not data-driven in the same way, right? So they always had to, of course, motivate their existence in this AI era. And that was very interesting because they did splendid work on, for example, train scheduling optimization and things like that. That was what they specialized in. So the question was whether I've seen other things than optimization as applications. Well, what about computer vision? I know you have talked about computer vision quite a bit in the podcast, right? That's something, I guess, that wouldn't be count as optimization in this?
Well, depending on how. Maybe the thing is that when you hear the term optimization, as you just explained, it's maybe a different use case than the one that I meant. No, if you use vision at the end of the line quality inspection, that's in the end. It's if that was part of your, if I may use your terminology, requirements engineering, maybe to say, we need to improve our wastage. And we're going to use database, machine learning, vision, and we're going to improve scrap from 10 out of 100 pieces down to 1 out of 100 pieces. Then that's what I've been calling optimization. So.
I see. So the way I used optimization, already a while ago in this interview. I mean, I talked about optimizing the different qualities that you might want to improve somehow by using AI. So it was actually optimization not of the product or process, but as part of the requirements engineering activities, where you have different qualities and some might contradict each other, some might support each other. And then there are ways to balance those, to strike the right balance between different qualities in the requirements engineering process. So that's part of the trade-off analysis there.
Now, interestingly, and maybe that brings me to the next question. Of course, it's like different communities may be using the same term in a different way. So, if we talk about then, so can you maybe confirm that, and you say, there have been people doing requirements engineering since, if I understand correctly, the 1960s. So can you talk about, are these different communities, like in many cases always, if we're going to say, there's many startups today that have, learned to do something with data. They provide database, machine learning, artificial intelligence services to companies for whom this is maybe new. So are they today two silos as communities, and do they need to learn to be working together rather than separated?
Yeah, I mean, the silo effect is there, of course, and it's a good idea to look across the silos always. So I think the requirements engineering community also needs to do a part of this. I mean, needs to work more with dissemination and outreach to make sure, I mean, the competencies that can be offered are also kind of promoted and marketed in a good way. The funny thing, I think, with the requirements and requirements engineering is that even if you do not do any requirements engineering, there will still be requirements, because I mean the requirements, they don't care if you make them visible or not. I mean, there will be implied needs and expectations by your end users. So either you work with them or you just do your thing, and they will still be there in the background.
Well, at the end, your marketing colleagues are going to ask you, okay, colleague, what is it that you built? What is it that I should sell my customer? What is it that we have to offer, right?
Yeah, sooner or later it will pop up.
Right. I mean, independent of what at the very beginning we talked about, you can build a piece of software, put it in the App Store and see what users do with it. That's probably completely on one side, without any. Somebody needs to put maybe at least one claim onto it, right? One word for people to then download it on one hand, and then on the other. Maybe a way of looking at these different approaches is also to look at the different perspective from development on one hand and operations on the other hand.
Yes, of course. And I think that many of the data scientists prefer to look at the development side and are less interested in the operations. But again, I think this is where requirements engineers could come in and help bridging this gap. There are many gaps to bridge, and I think requirements engineers as a profession are good at building bridges, so to speak.
Right. I'm not sure we're talking about machine learning operations today, but at the end, any data scientist, maybe not in theory, although they should also learn that in theory, that they are not finished, just providing whatever kind of wonderful model they have produced and say, here it is, put it in the production line. Thank you. Bye-bye. Here's my bill, my invoice. But no,
that's also related to the death by proof of concept thing we talked about before. I mean,
really?
Okay. It starts off. I mean, once you have a proof of concept, I mean, there are so many new flavors of life cycle management to tackle when you have an AI-based solution. So it's non-trivial, of course. I mean, you have. Yeah, we're talking about software development now, or systems development in which both code and data dependency must be under strict management control. And it's really configuration management on steroids. And there's plenty of the glue code that, glues small pieces of code together to make all this infrastructure work, and new hardware probably. And then you have the continuous evolution and the MLOps perspective. And it's not so easy. Where you have the POC, and probably it's a POC that has been, customized for a particular low-hanging fruit, and it might be hard to reach the generalizability that you wanted to have as well. So yeah, there are many aspects here to discuss. And I think requirements engineering can help to make some of those expectations you have explicit, and that will help you.
Share some of them with us then, because you talk about opportunities for requirements engineering to contribute to 6 specific machine learning project pitfalls. Not sure I need to mention them here, but, can you talk to 1, 3, those that are important for you?
Our main message here in the paper, what we really push for here and try to convey, is the following: that requirements engineering, it provides an overall framework and a big toolbox to discuss expectations and needs related to machine learning-based systems. And we know that there are variation points here compared to conventional software systems. The characteristics of machine learning, it does influence how these must be managed, the requirements. But there are already available requirements engineering methods and practices off the shelf that can be used today to help machine learning engineers and also, in that sense, support reaching industry-grade AI solutions. So in the context of AI and ML, there are inevitable decision points during the development, right? Where this structured analysis provided by requirements engineering can come in handy. And ML engineering, it's of course full of trade-offs where engineers must strike a balance, and doing so with more analysis and less gut feeling can mean quite a difference. So 2 examples. I'd like to first bring up the one about false positives and the false negatives, and the cost of these, because these costs totally depend on the application, right? And this necessitates cost-benefit analysis of various sorts. And striking the right balance here, it must happen here in the intersection of business or domain understanding and technology. And that's where requirements engineering as a practice really thrives and comes out at its best. Requirements engineering, it is this discipline that connects different stakeholders with different backgrounds. And this can really turn into a vehicle for accelerating the maturity of industrial AI. And the second one then, I think also is very applicable to machine learning projects, is about decision quality baselines and release management. So how good is good enough? This ever-present question, right? So where are the major cost barriers when developing a machine learning-based systems, and what to strive for when improving the performance? Which barriers should be broken here, and when should the organization and the project maybe settle for less? And the ideal quality level is perhaps probably not the best quality, right? So there are tools here in requirements engineering for setting quantitative targets, and also empirically proven models about connecting quality levels to, the actual perceived utility that the users have. And these are available, free to use, and please do so. And there are 4 more examples in the paper itself.
Okay, yeah, it's a very big topic, I think. And what is so interesting again is that many times my brain then brings somehow all these different market segments, which until lately had nothing to do with each other. So up comes here now medicine. We just talked about how, still many people around us are under the weather. We talked about, COVID-19, and there's all these tests. And then, so our friends in medicine, they have exactly the same right. They need to know exactly from these tests how many false positives and how many false negatives they get. Actually, there will be regulation by, at country level that tests will only be allowed onto the market with certain specifics. So that's so interesting to me, that where we, in manufacturing, and let's say in medicine, just to make that comparison, it will be, as I say, probably it will be medical people, medical domain experts, doctors, together with the regulation people at the countries. In our case, if we say, we need to know exactly what, in our case of a production line, a false positive means and what a false negative means, it will be, the production responsible people, again, who are in charge of deciding, how much product at what quality comes out of my production line, right?
Yes, and medicine is a good example and an analogy here, I think. I mean, it's also very important to not leave it only to data scientists to make those decisions in the design process. I mean, that's where requirements engineers are important to come there and help them understand things. And domain expertise is, of course, something you always want to have as a data scientist. But I think the requirements engineers can help everyone, speak the same language and make those expectations explicit, and that will help you.
Yeah, in the end, I would say whatever the person call themselves, but they have to be the domain experts. They are whatever kind of decision makers they may have had and will have in the future, more or less data, science, if it's only a day or a week, which is then not a data scientist who maybe has had 4 years education, but it will not be the person who did the model as a service, right? It must be the person who's in charge of the factory. For me, that's obvious.
Yeah, for everyone involved, I think it's obvious. Yes, we know that by now.
Yeah, and that person will more and more in the future understand what the data engineer, the data scientist has been doing. As you suggested, there's a couple of other opportunities here. You talk about decision quality baseline, underestimation of life cycle cost. Not sure that you want to talk to one or two of them. If not, listeners can download the article. Yeah.
Decision quality baselines is a good continuation here, I think. It follows nicely from what we just said. I mean, how good is good enough? This is always a tricky question, of course. It's something that everyone needs to answer when developing a system. And when you use machine learning to automate manual tasks, the performance gain over manual execution is often something you look at, right? And it's often what you're seeking to increase. So, for example, humans do something at 80% accuracy. The machine learning model delivers something similar with 90% accuracy, and then it's better, of course. But maybe this improvement from 85 to 90%, maybe that was very, very costly. And maybe anyway not generalizable to other cases. You had this proof of concept, but maybe it wouldn't work for another context. So then not so profitable, basically, to spend all the effort there. So, but without those explicit targets, the data scientists, we claim here, a little bit provocatively maybe, might overdo things and run over budgets. And we've seen many budget overruns in machine learning prototypes.
Sure.
And here we think that, the functional requirements from requirements engineers, we're good at setting quantitative targets in this business. And understanding how different quality levels map to utility levels. Perceived utility levels. How much better is it really to go from 85 to 87%? Because there is often not a linear relationship in the perceived utility here. There might be another shape of that curve. And there are good tools in requirements engineering to make those breakpoints visible.
It's more like exponentially many times, I believe, right? So the final another double cost. Right? Yeah, I think it's going to be for those companies that have been used to, and when I did 10 years with Intel, there was no thing ever that you were supposed to do without, setting a quantifiable goal, right? Everything had to be, quantified. Now, and that's the start, of course, and then you have to be realistic, of course. Yeah. And again, the domain expert will set that goal, of course, together with based on, whatever kind of experience of a data scientist. But if a domain expert knows that, the cost from going from, 87 to 92% is, out of reach, because that budget is not available for the next 2 years, that's then right. Then the domain expert will set the goal maybe from, 87 to 90%. Okay, so as we suggest, the other opportunities, maybe listeners can have a look at those that want, or also contact you. I'll share your LinkedIn address later. So, what is it you can share with us regarding, then combining, and that's a very interesting and important topic for me personally as well, combining requirements engineering with model-based design, for adoption of AI in digital industries?
The combination of requirements engineering and various model-based approaches has oftentimes been fruitful, and there are big sub-communities in the academic requirements engineering field that deal with this. So requirements engineering is good at variability management and setting up common platforms, then, making all those variation points explicit to support reuse in various ways. And with the right platforms, then the modular approaches and model-based systems can work tremendously well. And again, there is a very strong German sub-community doing this work. I don't have any specific examples of this. This is maybe not what we push the most in this column, but I would be happy to share some references to interested listeners. Just reach out to me on LinkedIn.
But my interest is also moving towards the next topic then. I mean, I come out of, and that's probably 30, 40 years ago, that was architectural computer-aided design. That's where I actually finished my degree in Delft, and combining that then with more generative AI. And I've been looking at it lately. It's not my, the topic I'm active in really, but it's more like a more general interest in seeing what it is that we can do with, different pieces of generative AI, and how that then works with, you were the one. And again, this morning when I recorded with Robert the news for the end of the year, which you listeners now beginning of the year may have heard already, we talked about, thank you very much, Markus, you made the reference, we talked about Alpha Code, for example. Maybe it's another, but that's another topic. Alpha Code is a piece of software that helps us maybe we want to talk about that specifically. So, but how do these new machine learning / reinforcement learning, some of them based algorithms, call them AI or not, how will we integrate them or not with the typical model-based design you listeners have been doing for whatever the last 40, 50 years?
Yeah, it's such an interesting topic now, and there's so much going on in this space. I mean, 10 years ago, it was deep learning coming with, beating classification task after classification task. And now we see generative AI doing so many cool things. And I, as a software engineering researcher, of course, I'm very interested in how well it can generate source code. And as Alpha Code, you mentioned. And this was Alpha Code was just the week before we recorded this, published in Science, but the preprint has been around since February 2022.
Oh, really? Oh, that long? I wasn't aware of that. Yeah. Okay.
Yes, the preprint was made available quite early, but now it's again discussed quite a bit. But I mean, this Alpha Code, it's part of a bigger movement in generative AI for code. We have, of course, GitHub Copilot. I don't know if you have talked about that.
Yeah, most certainly. I think most of our listeners who are active in developing, not all of our listeners will, but those that are, they will know Copilot as well.
It's old already. More than a year it's been available, right? I mean, it's
exactly.
Really one of the early ones.
Yeah,
I have colleagues using that all the time. They like it. So it's
and now comes ChatGPT, if we want to talk about that as well.
Yes, and that has been all over the place the last week. So I'm on mailing lists at the university, right? And I can tell you it's disruptive. I mean, it has already solved many programming assignments in our courses.
On one hand, but at the same time, we see that it has been, not allowed with certain, what is the name of that, the site that has, questions on coding?
Stack Overflow.
Stack Overflow, right? They are not allowing, what is it?
Good reason, I think. But it's so interesting that you mention Stack Overflow, because that has been also disruptive in software development. Every developer now, okay, I'm exaggerating, but it's very common that you have a tab open in your browser with Stack Overflow just to see how others did things for inspiration and, when you have specific questions. Yeah, so I expect us in the future to have yet another tab open with generative AI to get some inspiration from code generation as we go along. I think this is the future we're seeing.
Right. For whatever your job is, kind of, right. So if you're a code developer, and I must say that and maybe that was even the alpha code then, if you say it has been out for a longer time, is when I shared it on LinkedIn, I think, 3-4 months ago, and I said, we cannot exclude those people, and that is the people in, let's say roughly also people that do the code development. They think at higher levels, but in the end, they are many times the people who write it down as well. We cannot exclude ourselves, including myself and other people who kind of part of this movement. We cannot exclude ourselves. We put the world upside down, and I've always been saying that every job is changing, every single one. Some 10%, some 50%, some 100%. Jobs that go away, and we cannot think that our job, I received a big shitstorm at that time. Now, this time when I shared and you suggested it was now official, I haven't seen, it feels more like people say, okay, now we've understood, because what I understand that the Alpha Code is saying, they did tests, over 5,000 software programmers. They had more than 50, and they say all the people who have, shared their capabilities, they say they are in the top 25%, right? So, and they say it's not just a single, an if-then statement or something like that. It's more like, you are a coder. It's Monday morning. You sit together with your boss comes in and says, okay, the customer wants, and it's describing a project, I understand, at a higher level. And then still Alpha Code to be able to, come up with sensible solution, right?
Mm-hmm. Yeah, Alpha Code both interprets the programming assignments and generates code. So it works into it. Yeah, but in a very impressive way. But it's, for competitive programming, it's what it does. It's the DeepMind way of working, right? Everything is a competition, kind of. It performs very well in those competitive programming tasks, and that's cool. But I mean, we're not going to lose our jobs anytime soon.
Oh, I was going to ask you.
I mean, it's not like I'm going to recommend my daughters to study. So, I mean, don't stay away from programming because of this, because it's.
Oh wow! No,
it's not that bad, right?
No, I was going to ask you exactly that. I was going to ask you exactly that, because again, at the moment, because of ChatGPT, the creative people, let's say them, at least those on the artistic side of the movement, and then we talk about other generative developments like DALL-E and Stable Diffusion and Midjourney. That's where the community is really afraid they're losing their jobs, and they're forbidding on platforms, AI generated art. And then there's this huge discussion about what is art. Is art about, putting, a week or a year or hours of work into something and something comes out, or is it about a creative process? So you already say, yes, we're not losing. And that's very likely that the people who do the coding will not, but their work changes very structurally or not.
Definitely. So yeah, DALL-E is something else, I think. I know you have discussed that. I listened to some of your episodes discussing that, actually. And I've used it myself the last months, actually, to illustrate some of my pieces. And I mean, I first contacted various firms, illustrators, human illustrators. And then I tried to do something with generative AI, and I was happy with the results. So yeah, that's a little bit different there. But for programmers, I think what will be really, really important, and what we definitely must teach at the universities, is the combination of good prompt engineering. So you want to be able to feed the AI the right information to deliver useful output. And then, of course, critical thinking on the other side. I mean, you get something there, but you don't want to, at scale introduce software vulnerabilities or quality issues. So you must, of course, understand what you're doing. But I think this technique and this way of working will increase our productivity in software engineering. And this is important because there is a demand for software developers. There is a shortage, and the shortage will be a bigger problem. I mean, digitalization continues and accelerates. We need more source code, and we don't have enough people to write that code.
Strongly agree. And that's what we see here. Well, where I'm based in Germany, in Europe, I believe, we have a lack of skilled people everywhere. And what I see very strongly is that whenever we talked about automation me, myself, in an industrial environment, until lately, it was always on the side, okay, how many people are going to lose their job kind of thing. And that's been swapped 180 degrees, right?
Good.
We don't have people. We, we here in this country, we're thinking about where do we get qualified people from, which I think that's a completely different discussion, because how do we get the right to get qualified people out of other countries? It's almost like, that's a completely different discussion. But now we say, okay, automation, let's look at what automation / machine learning, artificial intelligence.
I'm happy to hear that. I've been 4 years on the board of a lobby organization, a software lobby organization in Sweden, and the education system just cannot provide all the resources we need here. So, I mean, it's good that the opinion then has shifted in Germany. Good to hear.
Let's look at then how, requirements engineering and the commercial side of AI solutions. What can you share with us on that topic?
Yeah. I mean, requirements engineering, it's a field that thrives at interdisciplinary collaboration. I mentioned that before. I mean, this is what requirements engineering is about, talking to various stakeholders from business to technical experts and domain experts. So why should we not leverage this for data science and machine learning projects? I mean, requirements engineering, it is a bridging concept, and it should become a tool then to bridge the still rather distant disciplines of machine learning and software development of the conventional type, where you use deterministic coding or business logic. Mm-hmm. That's one then. And the second thing is that our requirements engineering is good at mastering complex projects, and it has strong historical ties to the commercial side of things. Its business is a natural aspect in requirements engineering. So using that to support scope definition and dependency management between features and quality attributes. This is what we push in this column. Requirements engineering is there. Let's make use of the toolbox.
Okay, so then coming to a close, where are we then standing? And it's kind of referring to the initial little bit of discussion we had there, where we're standing as far as AI requirements engineering is concerned. In Europe, relative to, I mentioned before, maybe the software companies, internet companies from United States, China, Asia, and how is then AI requirements engineering going to change the world of industrial AI over the next, 5 or 10 years? Just a small question.
Just a small question. I'm equally invested, I would say, in two research communities. It's the requirements engineering community, and it's the software testing community.
Okay.
And the testing community has been a bit faster at acknowledging the new era of AI systems, I would say. The testing community was faster at providing various tailored testing solutions for AI. ARIA started a bit later, but now there is momentum for sure, and several PhD students really focusing on this topic. The research community in requirements engineering is already very international, but academically, I would say that Europe is in a leading position here, especially about trustworthy AI. And I'm sure you have talked about the AI Act, the proposed AI Act.
Sure.
But the big tech companies, as you mentioned, they have also done very impactful work. I mean, IBM is quite transparent with their work on trusted AI. Microsoft surely do impactful work as well. They have various quality models for different aspects of AI systems. And Some of them are rather similar to any software system, but some are more important when you work with AI. For example, fairness and reliability. And yeah, I'm sure you've discussed that.
Yeah, that's interesting to hear, though. The relation too. I'm not sure when we're finally going to see the AI Act, to be signed off. Finally signed off, and we're going to have a list of let's call it, I don't know if they are specifically called requirements list. And if you want to put your AI system, depending on at what level of making potentially or being potentially a problem or not for consumers, you will have to abide exactly by those requirements. So
yeah,
I didn't realize
they use the term key requirements on trustworthy AI, right? So
there you go. There you go.
It's in
right.
Yeah.
And so from that perspective, Europe certainly has been. Yeah, I think we were late to the market, but then, based on other things we've been doing like GDPR, it seems to be important for the European Commission to have this out sooner than later. And I've always been saying, and then maybe we finish off with one or two more words on exactly this topic, because then if a person like myself, says, yes, this is important, and I have been saying this for years because of what I was seeing, what was going to happen. And now we have an app, let's say like ChatGPT, out in the world to a huge community. And I had been mentioning, Robert, to say, there was this group of young people and they started using it and they were completely impressed, right? And haven't spent a single second on the idea, in the words of OpenAI, that sometimes ChatGPT will give, I think, quote unquote, nonsensical answers. It's the words of OpenAI, right? And these young people, they haven't been dealing with that. So, and I've been saying for that reason that it's so important that we get regulation. And if you then say they use the term key requirements, I'm very much looking forward to. And then, of course, you have the discussion to round it off to say, oh, that's us again. That's again. And typically you hear it in Germany, not sure about Sweden. Oh, that's again the old German approach. We always have to do everything, completely specifically. And maybe they mean indirectly the requirements. And then they say, oh, look at these, US companies. They do whatever they want to do. They put it up. And if it's wrong, they do it again. So is that still the world in which we live? And is that world going to change over the next couple of years, this division maybe?
Yeah, I heard someone describing it as, US, they have the research, China, they have the data, and what do we have in Europe? Well, we have regulations, so let's turn that into an advantage, right? So yeah, I think we will remain quite focused on regulations within the European Union, and for good reasons, I must say. So yes, I think this is not going to change in the next years. Let's see how fast it gets approved now. I mean, there have been many comment letters and a lot of debate regarding, especially, I think, the AI definition here. That's a tough nut to crack, of course.
I've seen a change in the fine. Well, in the last version that I've read. So they have been listening at feedback from the community. Yeah. Okay. Yeah. Well, keep our listeners up to date on that one. Certainly next year or this year, as you are now listening to it as well. So, Markus, thank you very, very much. You already referred to your IEEE paper. We'll put a link in the podcast notes, and listeners that want to get in contact with you, they can do that best probably at LinkedIn, Markus Borg, Markus with a KBORG, Markus. Otherwise, if you, the listeners, if you have any question, any comment, as always, please send a short email to peter@aipod.de. I'm very happy that you stayed with us so far. Looking forward to have you with us again next time. And Markus, thank you again. See you soon. I may be visiting Swedish friend over summer. I've been trying to visit for 10 or 20 years. Maybe it works this time. And if so, I'll certainly let you know.
Yeah. Sure. I'm on the gateway to the rest of Sweden here in the south. So that's would be fun. Yeah. Thanks very much for having me. There is so much to say about this topic.
Thank you. Bye-bye.
Bye-bye.